So question number 2. Question number 2, methanol is synthesized by the following reaction. So there's a following like this a reaction by which methanol can be synthesized. So a mixture of 39.5 moles of carbon monoxide, 77.5 moles of hydrogen was allowed to reach equilibrium at 550 atm pressure. Under these conditions, the equilibrium mixture contained 38.5 moles of methanol. Write expression for Kp. So as it's a homogeneous equilibrium, as all are there in the same state, so we write the equation for Kp, that is the product. But here because it's a Kp, so it should be in terms of pressure, like the pressure of the product divided by pressure of reactant. So Kp is equals to pressure of the methanol divided by pressure of carbon monoxide and pressure of hydrogen. But that should be raised to power 2. So this will be the expression for. So if you want to write, like it's not like a power is there or a superscript. So it is Kp is equals to pressure of methanol divided by the pressure of carbon monoxide and multiplied by the pressure of hydrogen, Mn square. Then the next one, complete the table for Kp under these conditions. So moles at the beginning are there and moles at equilibrium. So how to work out? As you need an equation, because to take a mole ratio you need the equation. So what is the ratio between carbon monoxide and methanol? It's 1:1. So if carbon monoxide and methanol is 1:1, so if we have 38.5, so this will be X cross multiply. So 38.5 moles of carbon monoxide will react, but we don't need how many react. We need how many moles are left at equilibrium. So originally it is 39.5 and reacted 38.5. So how many left? Left is 1. Because we need moles at equilibrium are the one which are left. Then we have carbon monoxide and hydrogen. So or we can also take methanol and hydrogen. It's up to you, with any of them you can take. So if you take, because methanol moles are given, that's why I'm taking those. So methanol and hydrogen, according to the equation, the ratio is 2:1. So if we have 38.5, this will be X cross multiplier. So it will be 77 moles will be there reacted, but we don't need how many react. We need how many left. If out of 77.5, 77 reacted, so left only 0.1, 0.5. So 0.5 and 38.5. Then the last part, that is the total number of the moles. So how to get the total moles? So we'll sum. So 38.5 plus 1 plus half 39 plus 1 makes it 40. So the result will be 40. When this reaction is carried out at 700 Kelvin and 50 atm, the value for Kp is small. Use this information, deduce the sign of entropy of the surrounding for the forward reaction. So when the reaction is carried out at 700 Kelvin, 50 atm pressure is there. The value of the Kp is small. So using this, we have to deduce the sign, because remember, for endothermic reactions, if we increase the temperature, the value for Kc or the Kp will increase. And if you decrease the temperature, the value of the Kc or the Kp will decrease. So how we can work out? So Kp is smaller, so the reaction does not complete. Like, so what does it mean? And for remember, for exothermic, like for endothermic reaction, when we increase the temperature, the value of the Kp will be higher. And if we decrease the temperature, value of the Kp will be lower. But for exothermic reactions, if we increase the temperature, the value of the Kp will be small. And if we decrease the temperature, the value of the Kp will be high. So, as I mentioned here, when the reaction is carried out 700, so it means that is the high temperature. So when the temperature is high, the value of the Kp is small. So high temperature or increase in temperature, the value of the Kp is small. So what it shows that the forward reaction is exothermic. Means this reaction or the forward reaction is exothermic. And one industrial use of methanol is production of the biodiesel from vegetable oil. Complete the equation. This is trans-esterification that we'll do in organic chemistry part. Like it will form an ester. So result will be CH2, CH, CH2, OH, OH, and OH. And then the other will also form because this whole part is removed and CH3 is attached there. So it will be CH3, OO, and CC5, C15H31. So this will form an ester and 3 molecules of that ester. But that we'll discuss in organic chemistry. In question 3, ethanoic acid and ethanol react to form an ester ethyl ethanoid. Expression for Kc. It's a homogeneous equilibrium. So it will be the concentration of a product divided by the concentration of the reactant. That will give us the value for Kc. By considering the effect of temperature on entropy change of a surrounding, suggests why changing a temperature has a little effect on equilibrium. So why the temperature, like by considering effect of entropy change on the surrounding. So what is surrounding? Surrounding is minus delta H by T. Entropy of the surrounding is given by minus delta H by T. If we change the temperature, the entropy of the surrounding does not change too much because the reaction is exothermic and it is slightly exothermic. So enthalpy change, you can see here delta H, the value of delta H is minus 3.5. So which is very small, like delta H is equals to minus 3.5 kilojoule per mole. So minus and delta H, which is 3.5, so minus 3.5 will be there and divided by temperature. So enthalpy change, this value is very small. So this value is very small if we change the temperature, because like very small value divided by a large value, that does not make too much difference. So enthalpy change of a surrounding is very small. So change in the temperature won't affect the entropy or enthalpy change of a surrounding, because the total entropy of is equals to entropy of system plus surrounding, and surrounding is delta H by T, and because the surrounding, like the enthalpy change is not there, or temperature, like enthalpy change or delta H is very small. So the entropy change of a surrounding will not change a lot. Then experiment was carried out to determine the value for Kc. 0.1 mole of ethanoic acid were added to 0.22 moles of ethanol, 5 cm3, 1 mole hydrochloric acid was added as a catalyst which contained 0.278 moles of water. Mixture was left. The mixture was titrated with sodium hydroxide to know how many moles of acid are there at equilibrium. So how to work out this? The total, first we need the concentration, or we need the moles. So first we'll get the moles of the initial moles are there. So how many, this assay, the sodium hydroxide is used, which is titrated with both of the acids. So these are the moles of water which are produced. So initial moles 0.12, 0.22. So ethanoic acid, ethanol, C2H5OH gives ethyl ethanoate, CH3COO, C2H5 plus water, H2. So using the concentration and volume, like this is the concentration and the volume of sodium hydroxide, so we'll get the moles of sodium hydroxide. The moles of NaOH, that is 0.045, because it is concentration into volume, and concentration is 1, so it would be 0.045. And out of this 0.045, how many moles of hydrochloric acid are there? 0.005 moles of 0.0005 moles of hydrochloric acid, because these total moles of sodium hydroxide is reacting with hydrochloric acid and ethanoic acid. So how many moles of HCl are there? That is again concentration into volume. So 1 into 5 divided by 1000. So 0.005 moles. So to know how many moles of remaining acid, like if hydrochloric acid this moles, how many moles of ethanoic acid at equilibrium? So it will be 0.04 moles will be there at equilibrium, because we'll subtract from the total. And using this, like we determine the moles of ethanoic acid, then the ratio is like these are the moles of ethanoic acid which are reacted with sodium hydroxide, or means these are the moles which are left at equilibrium. So if these are the moles which are left at equilibrium, how many moles are reacted? Like originally it were 0.120, out of that this left. So how many this was 0.220. So how many are reacted out of this? So 0.88 moles are reacted. So using the ratio, we will determine the moles of, like using the ratio 1:1 is the mole ratio. So we'll get the mole, this was 0, so this will be 0.08. And the water initial moles were there, that is 0.278. So we'll plus 0.08. So when we add, it will be 0.358. And this, the ratio is 1:1, so 0.08. This will also be used up. So how many moles are left at equilibrium? That is 0.140, because 0. So these are the moles at equilibrium. We substitute in the value for Kc, the expression for Kc, to get the value for Kc. So using sodium hydroxide, we got the mole, and using the moles of HCl, we got the moles of ethanoic acid.